Okay, let's dive into this. Today, we're talking about the absolute foundational mechanics of modern power. We're literally breaking down how raw mechanical motion gets transformed into the electrical energy that powers, well, everything around us. It's really just this elegant dance of physics. We're going to unpack the absolute essentials here. We're talking magnets, copper coils, and kinetic energy. That's the whole shebang that makes it all happen.
Our starting point today is this text right here, the principles of electric generator construction. Now, it sounds super dense, right? But instead of getting totally bogged down in a maze of complex engineering schematics, we're just going to focus on the essential blueprint it gives us. Because at its core, every single generator out there, whether you're talking about one of those tiny, hand-cranked emergency radios or a massive steam turbine inside a nuclear power plant, they all rely on the exact same fundamental physical interaction. It all really boils down to this incredibly dynamic, continuous relationship between powerful magnetic fields and highly conductive materials, all arranged in a very specific geometry.
Let's move to and see how this builds. Section 1. The core question. Examining the excerpt.
So the text actually distills this entire massive field of study down to just one single simple sentence. How is an electric generator made? So the crucial point is, this one foundational question leads us straight into the magic of electromagnetic induction. To actually build one of these things, you essentially just need two main components interacting with each other. First up, you have the stator. Think of this as the stationary outer housing, and it is just packed tightly with wound coils of conductive copper wire. Then right inside that, you have the rotor. This is the moving central axis, and it's equipped with a series of really powerful alternating magnets. Now, when some kind of external mechanical force, and that could be the kinetic energy of a crashing waterfall, wind catching a massive turbine blade, or even intensely pressurized steam, when that force makes that rotor spin at super high speeds, its magnetic fields continuously sweep across those copper coils in the stator. And it's this constant fluctuation in the magnetic field that physically pushes and pulls the free electrons inside the copper. It drives them all in a single direction to create a steady electrical current. You are literally using brute mechanical motion to force electrons down a wire. How cool is that?
And really, by understanding that a generator is basically just made by surrounding spinning magnets with copper wire, it totally demystifies our entire power grid. Suddenly, you realize that beneath all the seemingly magical convenience of modern electricity, it's just continuous, carefully engineered mechanical motion. We're just taking the brute force of a spinning turbine and seamlessly converting it into the current that lights up massive global megacities and powers our entire digital lives. Which actually leaves us with a pretty fascinating thought to chew on as we look ahead. If the fundamental construction of spinning magnets inside metal coils hasn't really changed in over a century, what entirely new, untapped mechanical forces are we going to harness to spin those rotors tomorrow? Something to think about. Thanks for exploring this with me today, and I'll catch you next time.